maybe it's this one. Okay, so you can find the link from, I think from one of my office hours, but I can mention again, and when, like I can add the link again, or maybe even add on the one of the R code folder. So in this simulation study, we use the Boston housing data. It has 500 observations, 19 variables, but I think I will end up owning like we use 50 and kind of one predictor and 15 variables. Okay. And we try a bunch of methods. I will just direct jump. We try the simulation 50 times. I'm just going to directly jump to the result. So this is a box plot. Let's just focus on the upper panel, because the second panel is about model size. Let's only focus on prediction error, which is upper panel. So AIC backward, AIC forward. Let's just ignore this. This is the result if you don't do any selection, use a full model, okay? And this is the result, you use lasso 1SE, lasso mean, and when I do lasso 1SE, I suspect, the lambda is too large, there could be a bias. So once I select the model, I will refit a least square estimate based on the selected variables. So this is called L refit. And this is a ridge regression 1SE, ridge regression, and lambda mean. Now you can, as I mentioned before, for this kind of a data set, you have over 500 observations, but maybe in your test, when we do this training and test split, we may have less observations, but still 3 digits and observations, at least 200, over 200 observations. And you have like 15 variables. There's no rate. If you care about prediction, just use a full model. There's no, you won't gain much by trimming some of the variables off. Now, so this is for, if I just use all of them. Now, if we go to a second example where I use the same data again, but now I'm going to have a data set and the number of features is going to be 135. How I get 130, well, actually 134, because one is the response variable. I have the original 15 predictors there, and then I add all the quadratic terms. And quadratic means all the numerical feature take square, and any 2 features, I include their cross products. So that's going to give me like 134 variables. One of them, like a Charles River, is a binary indicator. So that one, the square term, of course, is the same as the original one. So now this is a regression problem where P is 134. And also because those variables are like quadratic terms or cross products terms, they're highly correlated. And they're all sort of related to your prediction Y, because this data set, those features are not randomly gathered from the internet or any place. It's actually handpicked by experts or users or researchers, for the housing data. They know they're more or less are related to the response Y. So in this case, all the features are more or less related to Y. In that case, actually ridge regression is doing a very good job. So if you do ridge regression, again, focus on the upper panel, which is the prediction error, and the ridge regression with lambda mean the performance is actually pretty good. Now you don't want to use a full model because the sample size is 3 digits and the number of features also 3 digits, and just too many. Your least square on the whole model won't work very well. Because they're correlated, you see the ridge regression. So because they're correlated, you somehow want that kind of PCA there. Just keep that question in mind. I'm going to come back and to show another slide from my previous keynote slides. Okay, so this is Boston Housing Data 2, but what is Boston Housing Data 3? Here, you can see I add 500 more variables, and what they are noise features. I basically randomly pick a feature and just shuffle their observations. So you know that it's they're noise features. So there are 500 noise features. Now, so in this case, if you want to do PCA for those X, you're in big trouble because majority of your features are noise. They have nothing to do with your Y. So now if you still believe in top PC directions, you might be in trouble. And this is a case where you actually do want it to, so ridge regression overall is not as good as, lasso. So lasso still work with original variable. And even refit is not as good as sort of lambda mean. So lambda mean, you usually use a larger number of variables, but there are shrinkage involved. But quite similar, I would say. So sort of back to what Marcus' earlier question, for Boston housing, if you care about prediction, you just use a full model because the sample size is large enough for us to accurately estimate those coefficients. And let me go back, let me switch to the other set of slides.